SOHCAHTOA to find angles and to find missing sides on some kind of picture, some kind of story. The one we did yesterday was like a triangle, a right angle triangle that was cut. Remember the one that was like a big triangle with a little baby one cut inside it? That was a very visual one. Here is one that's very literal. In other words, everything is in words, yet we have still to try and solve the problem. So from the top of a 300-foot lighthouse, the angle of depression to the ship is 23 degrees. So there is my lighthouse. And here is the sea. And you have just told me that that distance there is 300 feet. And we're going to make the assumption that the sea is horizontal to the lighthouse. And they talk about from the top of the lighthouse, this thing called the angle of depression is 23 degrees. So if you don't know what an angle of depression is, let me tell you what it is. If you look horizontally that way, the angle of depression is the angle that you would look from horizontal going down the way. So they have just told me that this angle here is 23 degrees. And then we read on a little bit further. How far is the ship from the base of the lighthouse? They have just, oh, by the way, there's the ship, right? We are being asked to find that. And I'm just going to call it X because this is as good a name as any. So from that written description, I have built basically a little picture of it. And if you boil it down to its essence, what we have here is a right angle triangle where we know this side is 300 and we're trying to find this side X. And no, that angle where my finger is not 23 degrees, but I do want to know that angle where my finger is, right? It's not 23, but I should be able to find out what it is. What size is this angle?
67 degrees.
You want to tell other people, that's right. How you got that?
90 minus 23.
Does that make sense, guys? So just because they give you a number doesn't mean that number's in the triangle that you're going to use. See, the triangle I'm going to use doesn't have 23 in it, right? So be aware that, oh, well, you just look for a number, you look for another number, and then you do what you do. And you see that if you try to use 23, you wouldn't come up with it. Now, once you've got the essence of the story, which is a right angle triangle in each of these cases, you then take this angle and you name the sides. So I'm going to call this guy opposite because I'm trying to find his name, his size. And I'm going to call this one here adjacent. And the only two that I put my circles around are the things I'm trying to get and the things I know. And in this combination, would you agree opposite and adjacent are the two being used? So you go over here and one of these and only one of these will have opposite and adjacent in them. Which one of these three SOHCAHTOAs uses opposite adjacent?
Tangent.
And so now you know that the tangent is the guy to use. So the tangent is going to be opposite over adjacent. And the angle becomes 67 degrees. So the tan is 67 is going to be the opposite over the adjacent. And very often I put a little 1 there so I can do cross multiply. Sometimes you get lucky. And in this case we did, because the cross multiply is pretty much all I needed to do. Sometimes don't you then have to divide both sides by something, right? But not in this case. So I got my calculator and good. I'm going to type in something and it's going to be wrong. Doesn't look wrong, but it is wrong.
Are you in degrees or radians?
That's what I deliberately did wrong. So now I'll do it right. And so the missing distance is to the nearest whole number, 607 feet away. So that's how far that ship is. Now, in today's world, there's much easier ways to tell how far a ship is, but lighthouses were used for lots of things. The most obvious thing is there's a blinking light on it so you wouldn't get near the rocks, right? That was the way of keeping you away from dangerous places. But in military places, aren't lighthouses, at least in the olden days, wasn't that a good way to tell how far away ships were? And so how did they do it? They simply did a little calculation, not unlike this one. In fact, if the person on top of the lighthouse was not a mathematician, do you know they had another thing where he would just use his little guy and 67 degrees, and he would go to a book, and the book would say if it was 67 degrees or 707 feet away. If they're 42 degrees or 900 feet away, right? If they're this angle, they're 2 miles away, right? And so he didn't even need to do the calculation. Someone else, did it and put the answers in a big book, and he just measured the angle, and he was good to go.
I have a question.
Yes.
So when it says the angle of the depression, does it start at a horizontal line and it goes down?
Yes.
So how would you get it for, what is it called when it's like, what would the 67 degrees be called?
That wouldn't have a name, but can we turn the story and imagine you're on the ship looking at the top of the house, at the top of the lighthouse, right? So if a ship was looking upwards, which is, I guess, what you're trying to ask me, right?
Correct.
We call that the angle of elevation.
Okay, so if it's angle of elevation, you start at the bottom and you go up.
Yeah, so you're on the
Okay.
ground and you're looking up. That's called an angle of elevation. So that actually is the number you use, right? Because the angle of elevation is the angle on the right angle triangle. The angle of depression is you're at the top of something and you're going to look down to see it, right? So if you look downwards, it's an angle of depression. If you start horizontally and look upwards to see the thing, it's called an angle of elevation.
All right, thank you.
Okay, and that's the end of question 2. Let's try this one. Every question is kind of unique. So just because you saw that one, it doesn't mean the next one is going to be quite the same. So you have to teach each one on its own merits. So I'm just going to read this story to you. An airplane is flying at an elevation of 5150 feet. So here's the ground. And here's my plane. Yeah, really good plane, right? And you are telling me that the vertical height is 5150 feet. So far, so good. So an airplane is flying at an elevation of 5150 feet directly above a highway. Okay. 2 motorists are driving on the highway on opposite sides of the plane. Okay. So I got a car here. And I got another car here. And the angle of depression to one car is 35. So I'm going to have to put in more dotted lines. So if you went down this way to that car, the angle is 35 degrees. And even if it's not to scale, it doesn't matter. And then if you go on this side, the angle of depression, right? You're looking down. So this is the aircraft looking down at the cars, right? Not the cars looking up at the aircraft. And the other one, this angle here is 57 degrees. So that's that done. How far apart are the cars? So we are trying to find this distance here. Okay. So I'm going to take that picture and
Are those 35 and 57?
57, 35, yes, in my question. So the essence of this question is a triangle basically looks like that. This vertical distance is 5150. This guy might be 57, but that guy there is 33. And this guy is 35, but that angle on this side is 55. Are you okay with this guy here being 33 and this guy here being 55? Are you comfortable about how I got those numbers? Right. Now, they want that distance from here to here, but I'm not going to get that distance directly. I am going to find this distance from here to here, and I'm going to call it X. And then I'm going to find this distance here, and I'm going to call it Y. And then won't my answer be what you get when you add the two together? Does that make sense? You can't do it in one go, but you can find out what it's made up from. In this case, two pieces called X and Y, or A and B. And I've now created essentially most of what I need. I don't particularly need to do this, but some people find it helpful. If I just isolate this side here, then I want to find that, and I know that. And this is going to be what? An opposite, and this guy here is going to be an adjacent. And you see that that triangle kind of helps me pick the SOHCAHTOA, right? So in this little triangle, which is essentially the left-hand side one, I know the angle is 33. I'm trying to find this side here who's opposite, and I know this side here, which is adjacent. And that tells me that I'm going to be using a tangent. And so the tangent is opposite over adjacent. The tangent of 33 degrees is X over 5/150. And so little cross multiply, X is 5/150 times the tan of 33 degrees. And 5/150 times tan of 33, and to the nearest whole number, X is going to be equal to 3,344 feet. I'm not going to do the whole question, but if I then focus on the right-hand side triangle, this is the opposite, this is the adjacent. Can't I then basically do a very similar calculation? Can we pretend I'm making this number up, because I know it's not right, but can we pretend that the other one was 1,500 feet, just for argument's sake? Then my distance, the thing I'm trying to find, which is just X add Y, becomes the distance of X, which is correct, plus the pretend distance of Y. And that would be equal to 4,844 feet. And that's the method that we used, right? So don't quote me in that. That is not 1,500 feet. You know, do the calculation and find out what it really is. But for the method, that works. Are we good? Right. Now, next question is really not a puzzle question in my opinion, but they are in the puzzle section. So we're going to kind of show you what's going on. You're told that, and all they ask you to do is sketch what the triangle would look like. I'm going to make my triangle look like that because that's what theirs looks like. And from this angle's perspective then, opposite, adjacent, hypotenuse. That's not actually very helpful, because if you're going to use SOHCAHTOA, don't you need a fraction here? we talked about it yesterday. Don't you call that guy square root of 15 over 1? Which means the tangent, which seems to be very popular today, is the opposite over the adjacent. And that means that my triangle is going to have an opposite, which is the top, and an adjacent, which is that. Are we good so far? Now, to finish this picture off, all we need to do is find out the length of the hypotenuse. And can't we use that Greek guy called Pythagoras? And can you trust me? You can do the math, but it ends up being 4. And you are given 4 pictures, and one of them has those numbers and a theta in the right place. And you pick the picture that looks like that. Story for you. It's not a joke. Pythagoras, the guy who does Pythagoras' theorem, right, is one of those properties of right-angled triangles that have been known for millennia, for thousands of years. We grant Pythagoras as being the guy that discovered it, but they've actually found out that the ancient Chinese knew about it, and the Arabs knew about it, and the Egyptians knew about it. They all knew about Pythagoras' theorem. It's just that we happen to, say Pythagoras is the guy who got it. When it was discovered in various cultures, totally independent of each other, right? Because the Egyptians never knew what a Mayan was, right? They never even knew that they existed, right? But they somehow figured it out independently of each other. When the Greeks found out about it originally, at least the story goes, that it was such a useful piece of math, right? Being able to find missing sides and angles and things. If you're building objects or trying to find how far away the enemy ship is, right, from a lighthouse. You can imagine that's a pretty, today it doesn't seem great, but in those days, that was pretty high tech. Oh, you could tell how far something is away, right? Well, they kept it a secret. He didn't tell everybody. It was like a trade secret. The only people who knew about it were a group of mathematicians and scientists, and their group, their little secret society, was called the Pythagoreans, after Pythagoras, allegedly. And the story goes that the reason that Europe and we know about it is that the secret got out. And the secret got out, according to legend, because there was a woman mathematician who joined the secret society, and she was told about Pythagoras' theorem and lots of other clever tricks that they had, which gave them a kind of advantage over the people who weren't there, right? Because they could solve problems quickly that other people either couldn't solve or took a long time. So it was a good piece of knowledge. And evidently she told her boyfriend, who wasn't in the society, and he kind of blabbed, and the secret got out. And to finish the story, allegedly, the Pythagoreans weren't that happy with her when they found out it was her. So they took her out in a small boat in the Aegean Sea, and they tied her up with chains attached to rocks, and they chucked her over the side, and she died. So there is an example of someone being killed for nothing less than just knowing Pythagoras and telling someone else. So it was a difficult time in those days, right? Now I keep saying allegedly because there's a bit of sexism to that story, so I'm wondering whether that might have been just an old story brought about by male mathematicians insulting female mathematicians. Could easily be. Right, let's move on. We are going to look at our next puzzle. Oh, by the way, once you've got that, can't you find all 5 missing trig? I could say find the sine, cosine, tan, theta. Right. So I don't need to worry about those guys. So next thing we're going to, look at, where the heck is it? I'm trying to find my unit circle, so you can bear with me for a few minutes while I get thoroughly confused. Oh, there we go, this one will do. Right. Question 8, it's a different kind of puzzle. They ask us to evaluate, without using a calculator, the sine of pi upon 6 plus the cosine of pi upon 6. Well, there's pi upon 6. Which one of these numbers, the x or the y coordinate, is the sine of pi upon 6? Can you remember?
It's the y coordinate.
Okay. And the cosine is the x coordinate. And so what do we have? We have a y coordinate of a half plus an x coordinate of that. And so the answer is that, right? Wasn't much of a puzzle. As long as you know your unit circle and how to use it, you can do it. How about this version? Sine is 60 degrees times the cosine of 30 degrees. Again, not using your calculator. Plus the sine of 30 degrees times the cosine of 60 degrees. Okay, sine is 60 degrees. There's 60 degrees. The sine is the y coordinate. So that's root 3 upon 2. The cosine of 30 degrees. There's the cosine of 30 degrees. And that is the x coordinate, which is also root 3 upon 2. Plus the sine of 30, which is a half, times the cosine is 60, which is also a half. Now, square root of 3 upon 2 times another square root of 3 upon 2 gets you 3/4. And 1/2 times 1/2 gets you 1/4. Oh, isn't that amazing? The answer is 1. So that's a different kind of puzzle. Find the exact value of something, right? By basically using your unit circle. So we got any more of these guys? Okay, here's a really horrible one. The sine of pi upon 4, cosine of pi upon 6. Take away the sine of pi upon 6, cosine of pi upon 4, and then you square the whole thing. So we're really just going to be using our unit circle to find the exact values, multiply these together, multiply these together, take one away from the other, and then square whatever it is. So this should be pretty messy. That guy is root 2 upon 2. And the cosine of pi upon 6 is what? Root 3 upon 2. Take away the sine of pi is a half. And the cosine of pi upon 4 is root 2 upon 2. Okay. Those two guys get you root 6 over 4. Those two guys get you root 2 over 4. And then you're going to square it. And the safest way to do this calculation is to do it by thinking about FOIL. F-O-I-L. Root 6 upon 4 times another root 6 upon 4 gets you 6 over 4 times 4 is 16. This guy times that guy gets you negative root 12 over 16. This guy times this guy gets you negative root 12 over 16, and this guy times this guy gets you positive 2 also over 16. So since everybody is over 16, I can add the numbers together and get 8, and I can combine these two together and get that. So it's really just basically manipulating, you know, calculations involving sines and cosines from a unit circle. And you might think that is the best answer you can get, but it's not. Style points is what's likely to kill you in this question. Can you think of a better way to write the square root of 12? A simpler way?
2 root 3.
Right, so it's going to be 4 times 3, which is 2 root 3. So you're going to have 2 lots of 2 root 3. So what's that? 8 take away 4 root 3 over 16. Would you agree it's a little bit nicer? And you might think, hey, I'm good. Nope. Is there anything else that you can do to the top that might eventually make it even nicer?
Can we divide everything by 4?
We will eventually, but to do that, I'm going to pull out a common factor of 4. And then I can cancel. And now I have, there you go. So this question, this puzzle question, was really just getting you comfortable with manipulating and simplifying combinations of sines and cosines from the unit circle, right? They're not find missing lengths and so on. So let's return back to triangles with missing things. So in question 15, the triangle looks something like this guy. This is 25, and this is 45. And they ask you essentially to find everything, right? So find all the missing sides, find all the missing angles. And I'm going to employ a rule that I have a name for, and it's called just because you can doesn't mean you should rule. It's a made up name for this rule. You can get this question by naming the sides opposite adjacent hypotenuse, picking out the right one of the two to find the missing side, do all the calculations and get the answer, and then Pythagoras gets you the other one, and so on and so forth. And in most questions, that's exactly the route you should take, right? That's just because you can. Now, the reason why this one is just because you can doesn't mean you should. I can do this a different way. What's the size of that angle?
45.
As badly drawn as I've done this thing, isn't this a right angle triangle that also at the same time happens to be what's called an isosceles triangle? What's the length of this side here?
25.
Do you notice that I did that without using SOHCAHTOA or anybody? Now, there's one guy missing, the hypotenuse. That's the one that I will use Pythagoras on, right? So let's see what we get here. We want the answers rounded off to 2 decimal places according to them. So here goes. A squared plus B squared equals C squared. So it's going to be 25 squared plus 25 squared equals C squared. That's 625 plus 625 again. That's 1250. And so the hypotenuse is the square root of 1250 into 2 decimal places. We'll have our answer.
35.36.
Looks good to me. Now, could I have done it the way that you typically would have done one of these questions? You know, the ones where you name the sides and do all that? Yes, you could. I think it would probably take you 2 or 3 times as much time to do it, but it would work. So if you ever see a shortcut, think to yourself, just because I can do it the long way, doesn't mean I should, right? If I can find a quicker way, I think it's a good idea to take that road. And we're moving on to, which one? This one. Right. Basically find that total distance that they're calling x. That's the question. And 1 decimal place is the accuracy that they're looking for. I think you're pretty much got everything you need here. Would you agree? I don't need to really calculate much more. I can use almost everything that's in front of me. I would split this question, or this is one way to tackle it. I would split this question into a little guy called A and another guy over here called B. And won't X just be A add B? So that's what my brain is saying. That's how I'm going to solve this problem. I'm going to find the side called little a. I'm going to find the length of the side called little b. And if you add these two together, won't that be the question finished? X. Right. For those people who just like to separate out things, I don't think everyone needs to do this, but some people find it helpful. That's the left-hand side, right? That's the honest one now. Now, this side is opposite. This side is called the adjacent, and they're the only two that I'm interested in. Seems to be a tangent question, which I think everybody seems to be in this world. And what we got here is that the tangent of 60 degrees is 130 over A. When you do your cross multiply, you get A times the tan of 60 degrees is 130. And so the A is 130 divided by the tangent of 60 degrees. Let's see what that gets me. 130 divided by a tangent of 60 is about, well, what did they say again? 1 decimal place. That rounds off to 75.1. Is there any units? No, so 75.1. Right, to get B, I'll basically just have this side. There's B. And what else do I know? Well, this is still 130. And this angle here is 30. And this is the opposite. And this is the adjacent. And again, it's a tangent. And this time the tangent of 30 degrees is going to be 130 over B. You do the cross multiply. B times the tan of 30 is 130. And divide both sides by tangent. But try that again. Divide both sides by tangent to 30. And the second piece is 130 divided by the tan of 30. And I get 225.2. So the missing X is that guy plus that guy. So I get about 300.3. Are you comfortable about the approach of how I decided I was going to do that one, right? Pretty standard, you know, find two things, put them together.
Yeah, one question.
Yes,
If we're trying to find the exact value,
yes.
what would we enter in website?
If they wanted the exact value, you would have to do, let's take one of the calculations and show you what the exact value. Right, do you see this one here that was 130 over the tangent of 60 degrees, right? If you wanted to know the exact value of that, you would go to your unit circle and you'd find the exact value of the tangent of 60. So let's find out what tangent of 60 is. The tangent of 60 degrees is the y coordinate divided by the x coordinate. And for 60 degrees, you basically got the y coordinate divided by the x. A little trick here, if you just ignore the 2's, you get the answer. So this would be 130 over the square root of 3. And if you wanted to be a bit more precise, you could rationalize the denominator and get that.
All right, thank you. Yeah, that's exactly what I was looking for.
Okay. Now, let's not leave that question quite yet, because I think this is a candidate that you could look at in a kind of, no, I've changed my mind. I was going to say I could look at that a different way, but the way I was going to look at it is actually more work than this one. So we're done. This is an example of question 20. Try my best to draw the picture. You got a right angle triangle that looks like this. This angle in here is 60 degrees. This side here, 65. Then you kind of tagged onto it going this way, another right angle triangle, and it's going all the way to here. And we are being told that this angle here is 65 degrees, and we're being asked to find that guy. So far, so good, right? Now, we need a kind of strategy. And they want the answer to one decimal place, so I won't need unit circles. So I'm thinking about how am I going to get x? Well, I'm really not going to be able to get it right away. I'm going to have to find other things. On this triangle here, and I'm going to put the names on them, there's a hypotenuse, there's an opposite, and there's an adjacent. On this triangle here, which of those three sides will I need to find first that will then allow me eventually to get x?
The hypotenuse?
You'll agree? Hypotenuse. And the argument goes something like this. Don't I need to know this side so I can use it on this triangle? This side here doesn't help, right? I could find it, but it doesn't get me any better closer to the answer. So the guys I'm putting circles around, do you see it's these two guys? So which one of the SOHCAHTOAs uses opposite and hypotenuse?
Sine?
So that is the first one, I think, today where we wasn't a tangent, right? We actually get to use one of the other two. And the sine is going to be the opposite over the hypotenuse. In this case, the sine of 60 degrees is going to be 65 over the hypotenuse. A little cross multiply, and the hypotenuse times sine of 60 degrees gets you 65. And if you divide both sides by the sine, you'll get the hypotenuse. And I go in my calculator into one decimal place. I go 65 divided by the sine of 60. And it's about 75.1. Agreed? So I can now go here and write in 75.1. Now, if I just focus on this right angle triangle here, then that guy there is the opposite. This side here is going to be the adjacent, and this side up here is going to be the hypotenuse. Great. Now I'm going to put a circle around the opposite because I know its value. And I'm going to put a circle around this guy because I'm trying to find him. And that ends up being opposite and hypotenuse again. Do you see that means use the sign again? Opposite, hypotenuse, sign. So the sine of 65 degrees is the opposite over the hypotenuse. The sine of 65 degrees is 75.1 over x. X times the sine of 65 is 75.1. X will be 75.1 over the sine of 65 degrees. And 75.1 divided by the sine of 65. And I have thought of a mistake, not a major one. It might not even matter. They want the x to be to 1 decimal place, which is totally fine. Do you notice I rounded this guy off to 1 decimal place and then used them later on here? What that could mean is that the real answer, you know, the one Weber sine was expecting, could be 82.8, 83.0. So it probably would have been a better idea, too late to fix it now, that I actually used that version here. Right, that was what it was. Now, if I did that, let's just see if that would make any significant difference, because sometimes it makes no difference at all, in which case, yeah, I don't care.
Yeah.
Can you see that the answer ends up being 82.8? So can you see if Weber sine's being, you know, fussy, couldn't you do everything right and then it says you're wrong? Not because of the method, not because of something you did wrong, because you never did anything wrong. Wasn't it just this rule? So I broke my own rule here, and guess what? I shouldn't have. If you want the final answer to, say, 1 decimal place, don't you do everything else to at least 2 or 3? And only once, right at the end, do you round off anything to 1 decimal place. And that will stop you getting the, well, I did it right, but Weber sine didn't like my accuracy issue. Are we good? Right. Let's talk about the last one, question 21 for today. We have a right angle triangle that looks like this, and a line going like that. So there's a right angle in here. That's a right angle. This angle up here is 30 degrees. And this side is X, and this side is 7. And pretty obvious what we want then, right? We want to know X. I put a little corner symbol in there. We need a strategy. Since I don't have time to actually do this question, we'll just talk about how I would do it. Now, I know I want to find this distance X, but that's at the end, right? I'm going to find other things first. So if you focus on this top triangle up here, you see this one up here? Why am I going to find this angle, which happens to be 60 degrees? Why am I going to find that angle in there, which is 60 degrees? What am I going to use it for?
So that you can find the angle of the other triangle.
And that ends up being 30 degrees. Now, once I've done that, don't I basically have everything I need? Agreed? Isn't that enough information to find X? So in that question, I didn't need to do too much work. You agree? I just needed to realize that I needed this little angle to figure out that one. Well, and if someone's wondering, why do I know that's 30? Well, if this angle is 60, you notice that's a right angle, 60, 90, 30, 90 degrees. And that's where that came from. Now I could, oh God, I could do this question scenic route. Couldn't I find the length of this side and maybe the length of that side, right? And then once I know the length of this side, maybe I could find this angle, because if that's 30, isn't this 60? Right? And then make a big triangle. And then once I got my big triangle, finally get X. Couldn't I have went a really scenic route with lots of extra lines, with lots more working than really I needed to do? And so always try and be efficient, right? Just because you can doesn't mean you should, right? That just means do it the best, simplest way, always first, before you start doing it any complicated way.